My name is Osmar Zaiane, and I've been talking about this, but I'll be talking today about the promises and the perils of AI. This lecture is divided into 3 parts, and today I'll be talking about what is AI and give you kind of an idea about the past and the present. On the 5th of October, I'll tell you about, well, how we look at the future. I mean, some people are very afraid, some people are optimistic, and I'll tell you about that. And then the 3rd part, which will be on October 17th, correct me if I'm wrong.
Yep.
So there'll be 2 weeks in between, 10 days. I'll be talking about machine learning. So how does it work in reality? Okay? So, before I go forward, I want to ask the audience, are you taking the elevator today?
I have.
Oh, you have taken the elevator.
Yeah.
So, did you press the button to express which level you wanted to go to?
Yes.
Yeah, okay. Well, do you know that not a very long time ago, you didn't have to do that? Because there was somebody in the elevator called the elevator operator who was doing that for you. That was a profession. It was a real profession. And actually there was training for it, and people get a license. So this is an elevator operator's license from 1921, so barely 100 years ago. Now who thinks about that profession today? It doesn't make any sense. Anybody can press a button and go to the level that they want. But that was a profession. Yet, it's gone, and nobody thinks about it. If we didn't have these in the museum, we wouldn't even consider it. Well, look at this picture. Who's this guy?
Street sweeper.
Yeah, he's on the street. He has a broom, and he's very well dressed. White uniform with a white helmet. Well, that guy was extremely important in many big cities. Without it, we would be drowning, literally drowning, in horse manure. Because cities like Toronto, New York, Montreal, Chicago, Philadelphia, they had hundreds of thousands of horses. And every day on the street, you just had horses. Well, now they're replaced by cars and trucks and buses and trams. All these were pulled by horses. And the horses, of course, they leave things behind. Okay, apart the fact from they die as well. Every day you have tens of horses that are dying out of the hundreds of thousands. And these guys were responsible to clean the streets. Okay? Yet, they disappeared. That profession doesn't exist. And we don't even think about it. We don't talk about it. People don't even know. This is called a scavenger. A guy wearing white, the job was called a scavenger. It was very well paid. Actually, they were part of the middle class in New York. It's amazing when you think about it. There are many other professions that disappeared. Grooming these hundreds of thousands of horses, saddler, the whipcord maker, to make the whips, the cad, the smith, and so forth. All these jobs disappeared before I go there. And what killed them is the automobile industry. And the automobile industry was introduced as a clean technology because it didn't poop. Horses did. But, well, they didn't think about the other pollution that we think about it today. But at that time, it was introduced as a clean technology. And it killed all these jobs. Today, well, there are many jobs that are being also, there are many professions that are threatened, seriously threatened, or radically changed. Bus driver, we have now buses that are autonomous, professors, journalists, cashiers, you name it. All jobs actually are threatened. And who's the threat? Not the automobile industry. threat is AI. Okay, so that's what we point the finger at now. AI is responsible. That's the new threat. So we're doomed. We're doomed. Computers will take over. Robots will basically force us to retire. And actually, many people are telling me, hey, look, when I go and look for a job, and I go to a website, it asks me to describe myself, I'm such and such, I have 4 years of geology and whatever, and then, oops, I get this question, are you a robot? And when they finally say, okay, should I say yes, no, I'm not a robot, and then they get the answer, sorry, we don't have a job that fits your description. So that's the proof robots took over. Well, in reality, when you look at the jobs today, there are many, 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 many jobs that didn't exist 2 years ago, 5 years ago, or maximum 10 years ago. So we have new jobs all the time. Online fitness instructor, who would have thought about that? Cryptocurrency advisor, social media influencer, a podcast producer, a drone plane operator, social media manager, contact tracer. This became, actually it existed before, but very rare, but with COVID-19, that was a big deal. Contact tracer. A virtual reality consultant, a prompt engineer. This is now a big deal. Okay, we can talk about it later. Okay, so this threat, actually maybe it will create many new jobs we don't think about. Because these, we didn't think about it, these career opportunities 5 years ago. Okay. So the message is where we have to learn and adapt to our environment, or if we insist, then we will become redundant. Okay. So yes, job will change. And all these specialties will need to be adapted, but new jobs will be created. Okay. So, what is this threat? Artificial intelligence. And I don't know your background about AI. I know more or less some of it. I know your background, but I don't know how much you know about AI. But most people get their definition of AI, what is AI, from movies, from articles they read in the newspapers or magazines. Unfortunately, many of these writers or directors and producers doing these movies are portraying the wrong, they're portraying an unrealistic, basically portraying an unrealistic picture of what AI is. Okay? It's because we get them from these sensational articles or movies where indeed they point the finger at this danger called AI. Them against us. Okay. But if you look at these specialists, what did they say? Marvin Minsky, who was one of the pioneers of AI in the 50s, and was the, he passed away like 4 years ago, I think. He was the one who created the first AI lab at MIT. He said, artificial intelligence is the science of making machines do things that would require intelligence if done by humans. And officially, if you look at, I don't know if I got it from Wikipedia or from one of these textbooks, artificial intelligence is a discipline striving to get machines behave intelligently by performing tasks that would normally require human-level intelligence. So it's a discipline that we teach in all universities today. For me, AI is simply a tool that will enhance our creativity. Okay. And indeed, it's actually, if you look at it more closely, what we used to call AI may not be AI anymore, and what we call AI today may not be AI tomorrow. It's a moving target, it changes. There's one analogy that I like very much that Steve Jobs used many times when he was talking about his computer. He said that in the 70s, he was watching, I don't know, it was Scientific American or some, an article that talks about how different animals move, and somebody calculated the performance of this movement. So basically, how efficient these animals were in the locomotion based on their weight and based on the force that they put to move 1 kilometer, let's say. And then they ranked them. And humans were very bad. In that article, I think, according to, I didn't read the article, but I heard Steve Jobs saying it many times. I think he said, we are below the 1/3 of the animals. And the best, the most efficient animal was the condor flying. But the article, he insists that the article, at least the authors of the article, were clever enough to also compare not only the human walking or running, but the human using a bicycle. And when they put the human using the bicycle, the human was way faster, actually, twice as more efficient as the condor. And this shows you the importance of, right, we build tools to do things better. And then he said, our computer, he was talking about his computer, is our tool now, like the bicycle used to be. And what I could say, like Steve Jobs said, that's not the computer, it's AI. AI will help us actually become even more efficient than the computer, than the bicycle, and so forth. So that's why AI, we should look at it as a tool that will help us enhance our creativity. So what is AI? And this is another term that people use often, and we'll talk about it in more detail later. Machine learning. How does a machine learn? Well, AI, as I said before, is a discipline, and it's a discipline within computer science. So if I represent computer science in this sphere, or ellipse, AI is a subfield in there. I made it big because I'm going to zoom in, but it's as important as other subfields, like networking, high-performance computing, software engineering, graphics, database management systems, security, and so forth. There are many disciplines in computer science. One of them is artificial intelligence. Okay? They're as important as any other field, but I'll make it big just because I'm zooming in. Okay? Within AI, there are many categories, subfields. One is called machine learning, and I make it big, but there are other subfields like planning, knowledge representation, which we learn how to be represented so that the computer can use it, reasoning, so logic, computer vision, natural language processing. These actually merge a little bit with AI, with machine learning today, but there is machine learning, and I'll zoom in there. And within machine learning, how the machine learns, you have what we call supervised learning, but there are also other ways of learning, like unsupervised learning, reinforcement learning. There's many other ones, and the most important is supervised learning. And within supervised learning, there are different paradigms. One of them is deep learning. You've probably heard of deep learning because journalists now are using it. And often they use deep learning as synonym with machine learning, as synonym with AI, and they're not. Okay? So the message here is that deep learning is included in supervised learning, which is included in machine learning, which is included in AI, which is included in computer science. They're not synonymous. Okay. So this is what you should remember. Okay? AI in computer science, machine learning, deep learning within supervised learning. So deep learning is basically a rebranding of technology that existed also since the 50s, called artificial neural networks. and we'll talk about artificial neural networks later. They're basically trying to simulate more or less how neurons, artificial neurons, now they simulate the real neurons, but how they communicate via these connections, and they are organized in layers. We call it deep learning because we have many layers. It's deep learning. And I'll get to that later. And by the way, if you have questions, don't hesitate to ask. So what is deep learning? So deep learning is an approximation of how basically the brains function. We don't have neurons just in the brain, we have neurons elsewhere too, even in our guts. But anyway, so we have a representation of an artificial neuron. We have we call the soma. So it's a function that sums all the input. So you have many inputs coming from the different dendrites, let's say, and each one has a different weight, different strengths. And I'll sum them here, and then there's an activation function that decides, oops, now is the time to send the message. And it sends a signal through the output, which represents the axon. Okay? And that signal here can connect to many other receptors. And that artificial neuron, I can organize it into layers. Each one of these is a neuron. And the first layer is called the input layer. The last layer is called the output layer. And then I have many what we call hidden layers there inside. In the olden days, computers were not strong enough, fast enough, big enough to have a very complex neural network. So we typically had an input layer, one hidden layer, and one output layer. With time, computers became way more sophisticated and more powerful. We are able now to add way more hidden layers, and that's why we call it deep neural networks. This is a very simplistic representation where every single neuron is connected to every single neuron on the other side, but there are many other architectures, very sophisticated architectures that now we can do with the computers that we have. So we have deep neural networks, of course, we have convolutional neural network, recurrent neural networks, LSTMs, and so forth. That transformers. So the pioneers, it's odd to say that because I said the technology existed since the 50s, but actually for a long time people worked on this and then they gave up. It wasn't trendy anymore. However, there were some people who persisted and worked in the shadows. These people are what we call pioneers nowadays, the pioneers or the grandfathers of deep neural networks, and they're both in Canada. Yoshua Bengio from the University of Montreal and Jeff Hinton from the University of Toronto. And then suddenly in year 2010, they came back to the surface and became trendy again. Why is it? Well, there was one event that changed everything. In exactly 2012, there was actually a competition, and the competition used 14 million images of all sorts of things, from buildings to people to flowers to vegetables to whatever, animals. And the competition was about creating a software, a piece of an algorithm, that given an image will tell you whether it is an animal or a device or food or building or whatever. This is what we call a classifier. How do you build a classifier? And that competition existed before, so in 2009, the best performance, the accuracy was 70%, and then the year after it improved, the winner was 71.8, and then in 2011 they reached 74% accuracy. And it's interesting to notice that typically the humans, their performance is around 85 to 90% accuracy. So the computers were way below the humans. And the experts who use these images regularly reach an accuracy of 95. Why? Because some of these images are actually difficult. You see a rhinoceros from the back, well, you don't know if it's a rhinoceros or a hippopotamus or something else. It's not that trivial, okay? Anyhow, in 2012, the winners, using technology that now we call deep learning, but it was a surprise to everybody, and using GPUs, these are graphical processing units that people playing games use on their PCs, they reach an incredible accuracy. So it jumped from 74 to 83%. People are surprised, oh my gosh, how did you do that? Well, I use neural networks that we call now deep learning. Okay? And then after that, year after year, people worked on these now new sophisticated architectures, and they reached the human performance, and then now they surpass the human experts. So in deep learning on these 14 billion images, you can do better than the humans that are playing with these images every day. Well, can they do better than just recognizing images? Well, Google hired the team of the students and the professor, and they tried on images that they have to recognize cats and dogs and crocodiles and kangaroos and whatever, and they did very well. But then people said, okay, can we do something else apart from the images? Well, there was another competition that was running from the 90s. This is a switchboard data set. DARPA was asking different companies to try to help them get transcripts of recordings, people conversing on the phone. So hundreds and hundreds, if not thousands and thousands of hours, people talking on the phone, and they wanted them transcribed automatically. And then this is the performance, this is the error rate, so it's the reverse, it's not accuracy, so the lower the better. And this is the performance of the competitors year after year from the 90s till when we reached 2012. And then you can see they plateaued, it wasn't getting better and better, so it wasn't going down. And then as soon as they started using deep learning, it was getting better and better, and again, better than humans at recognizing the words said by people on the plane. Shock, again. So they tried it on many other things. This is object detection. It does better than humans. This is translation. They're not better than humans, but they're improving significantly. Visual question answering, so you give a picture and you ask questions about the picture. Again, we're not better than humans, but we are getting better and better, and so forth. So the advantage of deep learning, which is very interesting, compared to other techniques that existed, is the fact that the more data you give it, the better it gets. While other techniques that existed before, you give it more data, it gets better, but at one point it plateaus. It doesn't know what to do with new data. But deep learning keeps on learning until it actually does better than humans. And this was shocking to many people, and what was even more shocking and very controversial is when Jeff Hinton, who was the one who reintroduced neural networks to people with that victory with the 14 million images data set, he said in a press conference in 2016, he said, radiologists, we don't need them anymore. Computers will do better. Why do we need radiologists? This is the exact sentence he said. He said, I think if you work as a radiologist, you are like the coyote that's already over the edge of the cliff, but hasn't yet looked down, so it doesn't realize that there's no ground underneath it. People should stop training radiologists. And that really scared people. Is he right? Is he exaggerating? We don't know. Well, a year later, actually a few months later, not even a year, there was a special issue of Nature. Nature is the journal, the scientific journal. And this issue was talking about AI, and there was an article about dermatology. This is done by guys from Stanford University. They showed using a data set of 130,000 skin lesion images. 2,000 of them have diseases, and they showed that actually computers can learn from this data and can detect melanoma better than humans. So, oh my gosh, so Jeff Hinton was right. We don't need radiologists anymore. And of course, you get these sensational titles in different newspapers. So people were seriously scared. I'll give you an anecdote here. Here in Canada, the Royal College of Physicians and Surgeons, who are responsible for the training of, for the standards actually, the training of all the new doctors, and they connect with all the universities telling them what to teach, what not to teach. They have to scratch their head. Should we actually recommend courses in radiology or not? This is a whole generation that we can sacrifice for nothing if computers will replace radiologists, so that's an issue. So they created a task force in 2018, so a year later. They invited experts to write a report, to give them advice what to do about not just radiology, but all the other fields, pathology as well, and other fields in computer science, in medicine, but not only AI, but other technologies as well, like 3D printing and so forth. That will change completely, radically, medicine in the future. So I was invited in that task force. I didn't buy Jeff Hinton's message, I have to admit. So they commissioned this report in 2020, and basically we insisted on the fact in that report that AI is a tool that will enhance our creativity, this is what I said before, and that assists us as humans to do our job better. So actually AI will be a tool that doctors will use to do things that they were able to do, but now they will do them better, or to do things that they were not able to do. Luckily, they bought that idea, and they have a new task force that is thinking about how to embed now AI in the training of physicians and physicians and surgeons. And we were also lucky our report came out at the same time as another very interesting article that I like very much. So in this article, they had, I forgot, I don't have the data here, there were 1 million mammographic images, very high resolution. And they built a machine learning algorithm to detect breast cancer. But in this experiment, they hired radiologists. I forgot how many, like 14 radiologists or 20 radiologists, but anyways. And they asked the radiologists also to do the same thing as the computer. So the computer was supposed to detect breast cancer, and so did each radiologist. And radiologists would make mistakes. Computer would make mistakes. But then we can compare them. Okay? And what did they discover? Well, individually, on average, the radiologists will have area under the curve, so under the AUC curve, that's called the performance of 77% on average. The computer was at 87%, so way better than individual radiologists. But if you take all the radiologists together, then you do better than the computer. Okay, so 89%. We don't have the luxury to ask 14 radiologists for each mammogram, so that's utopia. But what you can do, oh yeah, there were 14 experts, but what you can do is they actually tried, given each radiologist the program, and they asked them to work together. Then the individual plus the model, they reach 89.1. So almost like the ensemble of all the radiologists together, which is impossible because it's too expensive to ask 14 radiologists. But it's very easy to give each radiologist the tool. The tool. So basically, the computer with machine learning is not competing against the radiologist, but can be used as a tool by each radiologist, and then they will be way better. This is in the case where you take the 14 radiologists with the tool, then you reach even more. But that, again, is utopia. But this is realistic. And so that shows that, well, it's an argument in favor of that conclusion that we made in our report, that actually AI should be a tool, and every single doctor should be trained to use that tool and not be afraid of it. And interestingly, there's the same message that was spread by Gary Kasparov. I remind you, Gary Kasparov in 1997 lost against Deep Blue playing chess. But after his deep depression, he started playing against Deep Blue. And then he realized that if he plays with a version of Deep Blue against Deep Blue, he can win. So he was going around the world giving this TED talk where he says, we should work with the computer as a tool and we'll do better. That's exactly our message. Any questions so far? No? Okay, so let me tell you a little bit more about what is this machine learning. How do they achieve these amazing results? How does the computer suddenly detect, in the mammograms, they detect cancer? Well, we use machine learning. So what is machine learning? So basically, you have data that is labeled. Okay? You have data that is labeled. Here, the labels, I'm representing them by colors. And what happens is that we have a computer program that goes over this data that is labeled and learns to distinguish between the different cases from different labels. Okay, so the label could be, for example, this one has cancer, this one doesn't have cancer, and so forth. And then we would learn something that discriminates between these different classes. So the colors here are classes. We call it a classification model. What's a classification model? It's basically predictor. It predicts whether something should be blue or red or green or this class or that class or that class. Then later, I have new data that hasn't been labeled. For example, new mammograms that I haven't labeled whether they have cancer or not, or whether it's benign or malignant. And then I will use that model. And by the way, that model could be a set of rules that says if I have this, then it should be that class. If I have this should be that class, and so forth. Or it can be a data structure, like here I have what we call a decision tree. Go this way or that way based on the attributes that I have. Or it can be mathematical formulae, or it can be a hyperplane dividing the space of possibilities. It can be a neural network. I mentioned the neural network. I'll tell you, I believe, in the last lecture how a neural network learns. Doesn't really matter. We'll put a face there on it. It's a function that given some x, it will give you back as output the class that x should be. We call it f of x. So now that I have new data that hasn't been labeled, I will use that model, and that model will predict for me those class labels. Okay. So I'll give you examples. I have email. You get email in your mailbox. Some of the email you open, you read, you answer, you store in the folder. Some of the email you delete. You never answer, you ignore, and so forth. That is behavior that can be used as data. This is the data, this is your behavior, and the algorithm will go over that and will learn what distinguishes between spam and non-spam. Now I have new email, and that new email, nobody told me whether it's spam or non-spam. Before even you see it, the computer will use that predictive model to predict which one is spam. It'll dump it automatically. Okay? Another example. I have data of handwritten numbers. Okay, people write differently. Is that a 6? Is that a B? Is that a 3? Or is it almost like a 6? I mean, people have different handwriting. And I have somebody who will label them for me. Okay? Then I go over that with the program, and I learn to distinguish between the 1 and the 2 and the 7 and the 5 and the 9 and so forth. Now I have a new check written by somebody by hand. And I'll use that model to tell me, is that a 0, is that a 3 or 5? It will tell me what it is. Okay? So this classifier will learn to read my handwriting and convert it to something that is real. Another example, mammograms. I talked about mammograms before. So somebody will label the mammograms and tell me these are benign or fine, and these have issues, and here where they are, there are regions of interest. My program will go over that. We'll build a classifier that will distinguish between the two classes. And now if I give it new images that haven't been seen before, I will use that model that I learned to predict automatically which one is benign and which one is malignant and where are the issues. I'll give you another example, completely different. Chatbots. So in a chatbot, you're talking with it, the chatbot needs to know what is your intention. So if I say, book me a ticket from Edmonton to Vancouver, it understands my intention is to book the ticket. Then we'll get the end, we call them entities, Edmonton, Vancouver, and then it may ask me questions because it's missing other entities, what time, what day, and so forth. What class, business class, or whatever. And this is how you make conversation. So the first thing you have to do is realizing what is the intention, what's the intent. Okay? So what we can do is give different examples. Hello, the intention is greeting. What's the weather in Toronto on Friday? The intent is getting the weather. Play burning down the house, that's playing music. So I have data, these are sentences, and I have labels, these are the intents. And then the program will go over it. Can I wait for you?
Oh no, go on, it's recorded.
Okay. And it will learn a class, no, not a class, a model that distinguishes between the classes. Now I give it a new utterance. What's the weather like in Edmonton? Well, the model will be used, and from that sentence I know, oh, the intention is get the weather. It's interested in the weather. It's not about playing music, it's not about booking a restaurant, it's not booking a taxi, and so forth. Here's another example. This is the example that she would enjoy. These are fundus images, so retinal images, and they are labeled by grade. This is what we call grading for retinopathy. Is it grade 0, 1, 2, or 3, based on how many nitroaneurysms and hemorrhage they have. Well, the model will be learned from this training data, and then when I have new retinal images, I can use that model to grade them automatically. Okay? So most of the data that is available for this kind of task are labeled, and we call it labeled on the image level. So the image is given to me and say, well, this is grade 3. It's not labeled at the pixel level. So when the model learns, it learns in general how do I distinguish between the different grades, so I can use it to grade these, but I can't tell you here are the issues. Okay? Because the data didn't tell me that. So we have actually a program that uses what we call transfer learning to learn not only to grade the image, but also to tell you where the issues are. So here are the examples of, this is grade 2, this is grade 3. Again, as I told you, the grades here 0 to 3 depends upon how many hemorrhage and microaneurysms they have. So we have most of the data is labeled at the image level, but we have the luxury to access very few images that have been labeled on the pixel level. Okay, so some ophthalmologists spend the time to label them at the region level. This is too expensive to do for too many images, but for few images. And for these very few, we learn another model that learns from this data set at the pixel level how to predict for each pixel what is the grading. And we do transfer learning from this model to that model. And we are able not only to grade the image, but to give you also a heat map on the fundus to tell you where are the regions that have high probability to have hemorrhage or microaneurysm. So the output, I don't know if you can see from there, you can get regions of interest on the image. Okay. It seems fantastic. I can detect anything with this. But it's not always rosy. And I'll show you some examples. What do you see here?
A desert.
A desert? Dunes?
Sand.
Sand? Yeah. It's obvious. I mean, you can show it to a kid, and the kid will tell you that. But this is an image that one given to a program that was specifically designed for police to detect trafficking of children pictures of child abuse and things like that, pedophiles. This was detected as a picture of nudes. It's obviously not, but they make that kind of mistakes. Here's another weird one. I don't know if you ever saw this picture. Do you know what this is?
A Ferrari.
A Ferrari. Oh my gosh, not only you said a car, but you said a Ferrari. You're right. Have you ever seen it in reality? This one, this particular one, this model, is actually quite rare. It's like $1 million or more. But we don't even see the wheels to recognize it. It looks like an insect or something like that. Well, if you ask the computer, it may tell you, oh, it's a horse. Because there's the logo of the Ferrari, it's a horse. Well, let's turn the car. Now I can see the wheels. Even if I've never seen this car before, I can guess it's a car. But if I ask the computer, it may tell you not only it's a horse, but actually it's a herd of horses. Because there's one here, one here, one here, there are many horses. So it still makes silly mistakes. Here's some examples that humans would not make. Examples of mistakes. A soccer player, because with deep learning you can also ask it questions for the image and you can describe the image. Here the description is a soccer player is kicking a soccer ball. I don't see him kicking the ball. It's in front of the ball. Maybe in the future, maybe in the past. Now in this picture is not. A street sign on a pole in front of a building. It's actually on the other side of the street. It's not in front of the building because we can see the depth. Here, a couple of giraffes standing next to each other. Are they really standing next to each other? You can see that it's far away here. So they still make some sense. It's already amazing that we can do that. But don't take it like as a solved problem. And you have to admit, some of the problems are actually even difficult for humans. Like this example. Are these bagels or puppies? You don't see from far away, I guess. What about here? Is that a chihuahua or a muffin? What if you put a chihuahua and a muffin in the same picture? these are actually images made on purpose to show the complexity of the problem. Is that chicken or is that a... Watch out what you bite here. It can bite back. Is that a dog or a mop? So that created a new subfield in AI where people are trying to actually fool the computer. What do I do on the picture to fool the computer? And this is very important, especially when now you have cameras that recognize people, you have cameras that recognize signs, is it turning, no turning left, or is it a stop sign, and so forth. People can do things on these objects or the images to fool the computer, and we need to understand that. What are the limitations? So here's an example. This is a panda. All you recognize a panda. This is what we call a gibbon. If you take a picture, part of the panda, this was published and they showed these examples, so I'm using the same example. This is a panda, and if you give this to the computer, that program, it will tell you it's a panda and I have a confidence of 57%. Well, it's not bad because you don't see the whole panda, it's cropped. Okay? But it says it's a panda, I'm confident more than half that it's a panda. But now if we add noise to that image, it generates this image. The humans will not see the difference. But for the computer, suddenly this image is a gibbon at 99.3%. That's shocking. It jumped from a panda to the gibbon, and from a confidence of 57% to 93%. So I'm very sure it is a gibbon. Yet it is a panda. It's actually the same image. I've just added noise. Here are some visible noise that people can add. This is a picture of a banana. And the computer says, the classifier says it's a banana. I'm very confident it's a banana. It could be a slug, but I'm not that confident. It could be a snail, it could be an orange, but I'm not confident. Very confident it's a banana. Now I add this picture right in the middle of the picture. Okay? It looks like, I don't know, it's a cell of some sort. I don't know exactly what it is. But if I give this image now to the computer, suddenly it's not a banana anymore. My confidence for being a banana is very small. But it's a toaster. It thinks it's a toaster. Okay? So you can see that you can fool these computers very easily. Even though, on some experiments, they show that they can do better than the humans at detecting mammography and so breast cancer or melanoma for skin cancer and so forth. Almost a year ago, there was a program that was released by OpenAI that made a lot of noise, ChatGPT. You heard of ChatGPT? Of course, everybody heard of ChatGPT, especially students, because they can use it for different things. ChatGPT, what is ChatGPT? Basically, ChatGPT is a model that learns to predict a word, what's the probability for a word to appear, given a sequence of words. Okay? So you can give it a sequence of words, that's the question, we call it a prompt. Okay? So you give it a prompt, and based on that sequence of words, it can predict what is the probability for a set of words, and takes the highest probable one and puts it there, and then now I have a new sequence, I'll predict the next word, predict the next word. It can, if it learns very well, it can actually generate sentences. Given a prompt, it generates a sentence. So here's a prompt that I can give it. Explain the difference between ophthalmologists and optometrists in the style of Shakespeare. I mean, ask a human to do that, it's not an easy thing. But, amazingly, it can generate a good definition of what is an ophthalmologist, what is an optometrist, and it does it in a sonnet like this, like in a Shakespearean style. This is very impressive. But when you know how it is done inside, when you know the secret, it's not as magical as what it is. But it's still phenomenal. Here I'm going to show you that it can make really stupid mistakes. I ask it, Mike's optometrist has only 4 patients. Martha, Martin, and Matthew. What is the name of the fourth patient? And it says the name of the fourth patient is not specified in the given information. And I say, but it's in the question. So I say, Mike's. And it says, I apologize, the fourth patient is not specified in the question. The patient's name in the question, so that the names are Martha, Martin, and Matthew, but it forgot Mike. So it doesn't do that reasoning that any human would do. And I keep on talking to it. So who's the optometrist? And it says the optometrist is Mike, but actually it's Mike's optometrist, possessive case. I didn't get it. I apologize for my confusion. You are correct. So it has this ability to apologize and correct its knowledge, and then I ask it, what is the name of the fourth patient, and finally it says it's Mike. So it still makes mistakes. Nevertheless, you can do amazing things with, we call them large language models, and there are many. ChatGPT is not the first one. It's the first one that was made public, and certainly not the last one. There are many, many that exist as well. And people started playing with these things. Here's an example, close to optometrists. There are students from, I believe, Stanford University, 2 students in the project. What they did, they have a microphone here that can hear a question, converts it to text, sends it to ChatGPT. ChatGPT gives the answer. The answer is transmitted and displayed on this screen that is put on, kind of a simple thing, but it works. Put on glasses like that, and then the person can read them. So they played the case of an interview. You have an interview. The questions are actually answered by ChatGPT directly. So ChatGPT was tested to rival students at different exams at the university, so university entrance exams, or even the MBA exam, or medical, US medical licensing exam, and it does quite well, surprisingly. It does it well, but without understanding anything. Even though it may pass the medical licensing exam, I wouldn't give it the license. It's extremely dangerous. But it's still impressive. So I can stop here 2 seconds, a few minutes to entertain some questions. Any questions?
So when you say it doesn't understand, I think there are instances where the answers do indicate that it understands, and not only that...
No, it doesn't. It may give the impression that that's what's happening. But what is happening is that I start with the prompt, which is the question.
Right.
In any answer and the subsequent utterances that I have, that I ask, they're added also to the prompt. So the prompt becomes big, and the prompt is storing the information of our conversation.
Mm-hmm.
And that's why when I said, hey, it's Mike. Mike is there's another one, it's in the name. When it takes the first prompt plus all the conversation, then finally it can predict that Mike is the fourth name. But it doesn't mean that there was a reasoning really happening. So people are trying to come up with tricks to add in the prompt. So for example, you can ask it to assume that it is a person who is doing this. So you can give it a kind of imaginary context, and because it's part of the prompt, it will be used in the prompt. You can ask it to explain step by step, so you force it to do thing, and that's why we talk about prompt engineering as a profession. It's not an easy thing to do, to come up with the right prompt to get you the right answer.
And I think many people believe that it can only give you information that's been inputted into it, but it actually can create new information.
So that's a very important point. First, we train it with humongous amount of data. So ChatGPT, for example, was trained till 2021, data that stopped in I think September 2021 or whatever. Any information after, so for example, you say, who's the president of that country, and if the president was elected or did a putsch after September 21, it will not know it. Okay. So that's number one. Number two, it has to generate something. So if it doesn't know, if it's not part of the predictions that it learned, it will select the next word anyways. So it will always generate an answer, whether it's true or not true. So it creates what I call fabrication. It fabricates facts. Technically, we talk about hallucinations. So these language models hallucinate. They give you fake information. It's not really hallucination, because in medicine, hallucination means something. It's fabrication of information.
Yeah.
I played a game with it, and I invite you to do the same. There was a journalist who tried it, and he asked ChatGPT to, I forgot the name of the, I think it was in the Globe and Mail, the journalist who did it. He said, who is, and he gave his name. And ChatGPT came up with an amazing biography, but he said, nobody knows me better than myself, and I'm reading this and I don't recognize myself anymore. So I tried to do the same experiment. I said, who is Osmar Zaiane? And it gave me a very long description of this amazing guy who has these awards and was born in another place, and it fabricated my life, which is wrong. The funny thing is that with ChatGPT, you can say, well, I didn't like that, can you try again? And it gave me another biography of myself, born in another place with other awards and other achievements, and it's not me. I sent it to the department, to my colleagues, and say, look what ChatGPT generated. Try it with yourselves. So people tried. And one of my colleagues ended up being dead. So ChatGPT said that he was born at this date and died at this date and gave achievements and stuff like that. So yes, it fabricates, because it has to say something, and if it doesn't appear in the predictions that it learned, well, it's wrong.
Yeah.
And that's a big danger. It can create, unintentionally, wrong information.
So
It doesn't say, I don't know.
yeah, so when people think about AI now, many people are much more aware of large language models than anything else.
Yes.
But Sam Altman himself says that we won't get to AGI through that route alone.
No.
So this new partnership that Rich Sutton has, they're planning to reach AGI in 7 years with reinforcement learning. Yeah. So there is a kind of local
They will
side
try.
to this.
They didn't say 100% we will get there.
No,
it's an attempt.
right.
And people
No,
miss
but
that. It's an attempt. I don't think they will get it in 2030. But that pressure will allow them to make incredible
But they
discoveries.
could get it sooner, right? Because we used to predict 2045 as basically this time, and so 2030 would be a lot sooner than that. So there's some imprecision there, right? You think it will take them longer, but it could take them shorter.
It'll take longer unless they make a discovery that nobody expected. But we need that pressure anyways.
Yeah.
We need that pressure.
Yeah.
What is missing here is reasoning. There's no reasoning.
Yeah.
So people are working on adding reasoning with, I mean, the language model is interesting because it learns it models the language. It knows better English than I do because it went through all of that text. So it can generate amazing sentences. I can't write the difference between optometrist and ophthalmologist style of Shakespeare, but it can. It can. I cannot.
Yeah.
So it can do amazing stuff for sure, but no reasoning yet.
It seems to me like AI is really good at doing specific tasks,
Yeah.
like identifying dogs from bagels, but then you give it another task that it wasn't trained to do, so even though humans can do that, it's just not as good.
No, that's a very good observation. Most of the programs are very specialized. We humans we can do many things at the same time. But people have been working on making these models also do other tasks. So ChatGPT, yes, it learned about the language, but you can use it for amazing stuff too. It can create a song, okay? It can give you a recipe for, these are completely different things. I can use ChatGPT to do also other things. I can give it some code and say, can you fix it? It can fix the code. But it's not as general as humans. But we're getting there, creating programs that can do more than just one thing. If I go back to Deep Blue that beat Garry Kasparov at chess, it can only play chess. It cannot do something else. It's excellent at chess, but lousy at everything else.
I have another question. So if you give AI, you don't give them anything to train with, can they learn without
Yes.
that initial input?
Yes, they can, and I'll give examples Thursday. Thursday. So now I want to talk about something completely different that probably will interest you, in particular, the bionic eye. So this is not an eye, this is an ear. This is just to introduce the bionic eye. I want to talk about the cochlear implant first. The cochlear implant has been around for more than 120 years. It's been around for a very, very long time. It's getting more sophisticated, obviously, but it allows people who have problems with their hearing to hear something by exciting the bone inside. There's a microphone that gets the sound and then amplifies it and transports it. It is transformed into basically signals through the bone, and then we can hear sounds. The same idea can be done with the retina. So in the last few years, people have created a matrix, a chip that you can put on the retina, and it can send signals that can go through the optical nerve, and people believe with those signals that they see something. And where do you get these signals? Well, there's a camera put on the glasses. You don't see the camera here, I think this is the camera. The camera sends the image to a processor that they wear around the belt. The processor changes it into very simple signals, sends back to this emitter. The emitter sends the message wirelessly to this chip. And this one sends messages to the optical nerve, like you get these through the bone here, and the person can see. So here are examples of what they can see. Because it's a small matrix, like 32 by 32, I believe in this case, and the picture of the bear, you can see the bear here with the paper. So you see these dots. You can see letters, so blind people be able to read. There are different technologies. This is another one where you can see a face. Okay. And it's amazing. And from nothing to seeing something, it's phenomenal. The interesting thing is that this is how the technology started. So this is 4 by 4, 16 by 16 matrix. This is 32 by 32. You can see a human. Okay. But what this reminds you of, the very old digital cameras. Today, the digital cameras have incredible resolution. So very soon, you have eyes that can see very high resolution. Blind people see very high resolution. So this is via the retina. There's a new technology that goes directly to the brain, okay, because the optical nerve can be damaged as well, so there are different diseases. So you can send the signal directly from the back. Okay. And this is what people could see in the future. This is a simulation from a real picture. If you saw this picture before, this picture was taken in 2011, 10 years ago, during the Stanley Cup in Vancouver. And there was a crowd, because not everybody could get in the stadium. So they had these big screens, CBC put these big screens, so people can watch the final game outside. And the police predicted that there will be a riot afterwards if Vancouver loses, or even if they won. People excited will generate some violence. So here's a picture taken by a special camera that the police installed to be able to identify those who are troublemakers. Do you notice this guy here? No, of course you can't. So let's try to zoom in. Person here. If I zoom in, I'll see this. That's the picture of the zoom in. Do you see that guy? Still difficult, huh? Okay, well, that guy here, let's zoom in. You see the guy? It's the same picture. Well, this guy here, I can zoom in even further. From that image here, I can see that. This is technology from 10 years ago. In 10 years, the cameras are way better today. If I was using a normal camera, I would get that zoom. I can't see anything. But this is a very special camera with 2,000 megapixels of 10 years ago. So imagine that now in the retina. They will be able, people who have this bionic eye, they will be able to see better than me or better than you. More than that. They can see also at night. Can you see at night? They will be able to see at night because it's a message sent by a processor. The processor can see in infrared and send the message through the chip. They can see also the heat map. And I can see where the bodies are. Okay? So, do you like the bionic eye? It's weird, but some people will start choosing to have a bionic eye. In addition to that, the processor that I have here can process information in real time and tell me that information. Will tell me that's a car, these are pedestrians, that's a sign, and can track them in real time. And it can be augmented reality added to my eyes, which I don't have now. I could by putting goggles and stuff like that, but still not the same. There is a paper that came out recently where they show also how they can do better. So imagine this picture. And I have this bionic eye. I can speak to the bionic eye and say, I lost my keys. I don't know where they are. I mean, it happens to everybody. And we are looking for the keys. They're right in front of us, but we don't see them. The processor will do segmentation of the image that I have in front of me that the camera can see, my eye can see. And then identify the key. And then the signal that is sent to my brain will enlarge the keys. So I can make them move. Then I can see them. Imagine this capability, which is possible technically today. This has been published in last year, 2022. So these are things that are possible. Let's put the bionic eye aside and think about what we call the smart lenses, contact lenses. And it's been around for a while. Google started working on this in 2014. This is a contact lens that detects the pressure on the eye, so for glaucoma. There's continuous monitoring of the pressure of the eye. What Google did also is a contact lens that measures the sugar level in the tears. So instead of, for the diabetic, instead of getting the blood each time and using a needle all the time, this is continuous measurement of the sugar level in the tears. By the way, this idea of smart contact lenses was patented for the first time in Canada in 1999. They were imagining it. It wasn't possible yet, so they patented it. Today, we have amazing contact lenses. Here's a contact lens built by a company. It has a camera and it sends signals to a computer and back and forth. So this is, it's very, well, you can see the picture of the lens in real. And it adds information. As you see, what you see, it adds to it information. So it projects in your retina with the projector here, projects in the retina additional information. Here, well, the video stopped here, but I'm at the airport, and it tells me, for example, which gate I have to go to, which direction, and so it guides me as I'm walking. And this is the case of an athlete on a bicycle. It gives you additional information about speed, and I don't have to look at my tools in front of me. I can see it directly there. And these exist already. So, yeah, the future is already here. It's just not evenly distributed. So the question is, I don't know if I have time, I ask you. Will optometrists still have to do something, or everything will be automated and the job is gone, like the scavenger or the elevator operator? Well, diabetic retinopathy is something that we can do very well with AI. So well that it has already been approved by the FDA. Okay, so the FDA has approved few tools already, tools with an S, and some optometrists are using them already. Some are assisting the optometrist, some are, well, still assisting, but actually giving you directly the problem itself. It helps a lot. But for macular degeneration, the AI is very weak. It's not very, yet, it's not good enough to be approved by the FDA. So not reliable enough for the FDA to approve it. But tools exist already. People are working towards it. For glaucoma, there's still no known successful AI, and people are working on it. It's going to get there. So we still need optometrists. There's no question about it. But the way they do their job will change. We'll have new tools that previous optometrists didn't have. So it's an incredible potential. And the optometrists will be replaced not by AI, that will be replaced by optometrists who know AI. And that's important. And I mentioned before that there is work on detecting from the fundus, from the retinal image, other diseases like Parkinson's, like Alzheimer's disease, like depression, and so forth, that no optometrist was imagining being able to detect. So now, if we have this tool with AI, new customers actually will come to the optometrist that didn't used to come to the optometrist. Okay, so to summarize, I'll summarize what we talked about. I mentioned about this person who existed about a century ago and had an incredible job. It was part of the, as I said, middle class. Now it's gone, and many other jobs will disappear like that, but not displaced by industries like the automobile industry for this particular case, by AI. AI will displace way more jobs. Or change them. So I mentioned about artificial intelligence and machine learning, gave you the big picture about AI as a discipline, and I mentioned especially the fact that deep learning is machine learning is AI, and AI isn't CS, but they're not. Then I talked about how machine learning works. So basically, you have data that is labeled, you learn a model, and then that model, predicted model, will be used to predict new images that haven't been labeled, and can label them for us automatically. That's what we call supervised machine learning. It's supervised because I provided with training data. I supervise it. I also warned you that, well, AI is not the solution to everything because it still makes mistakes. Then I talked about the bionic eye. I hope I convinced you that in the very near future, the bionic eye will be actually probably more powerful and better than the eyes that we have, that nature gave us, basically. Then I also talked about smart contact lenses that exist already today. So the final message is that we have to learn and adapt, otherwise we will become redundant. So, thank you for your attention.
Great.
If you have questions, go ahead.
So, because the time of the second and the third lecture are quite far apart, I think
The
the
second,
students,
oh yeah, between the second and third.
yeah, that the students will be anxious if they don't have PDFs of the first and the second
I will
lecture
send you.
soon. So if you could send me
I
that.
can send you this tonight.
Yeah, cool, yeah. It just makes them all much more comfortable.
Especially for those who didn't come.
Yeah,
Yeah, and if we give them the PDF early enough, maybe that'll convince them to come on Thursday.
yeah. Well, there'll be more here because of the fact that
They don't have courses.
Thursdays are sort of a free day for the medical students, so it makes it easier, yeah. Great, okay, well, thank you very, very much.
You're welcome.
Yeah, very optometry relevant.
Yes.